Okay, well, I think it's exactly on the hour, so let's go ahead and begin. So first of all, a very warm welcome to everybody. I know we have well over 100 attendees today for the webinar. So first of all, I'm very excited to be able to share my thoughts with all of you on what I believe are the 5 key steps for successful schedule risk analysis on major CapEx projects. Really, I guess, 2 main drivers for putting on the webinar today. First of all, as many of you know, Acumen launched a risk analysis software product late last year, and we've had a huge amount of interest in that tool, both from a schedule risk assessment perspective and also from a cost risk analysis viewpoint. Secondly, we're seeing more and more CapEx projects and EPC projects take advantage and utilize schedule risk analysis as part of their sanctioning process. And so what I'd like to do today is share with you really the key steps to successful schedule risk analysis. So first of all, just to set the scene, I'd like to give a brief introduction to risk analysis, why it's so important during both the planning but also the execution phase of a project, and then really dive into quite a bit of detail as to the steps that are required for successful risk analysis. As many of you know, not only are the steps potentially quite treacherous, but unfortunately, a risk analysis model, whether it's cost or schedule, is very, very prone to the variables that you feed into it. And so these key steps, these 5 steps, have been established and developed so that really you can try and avoid those pitfalls when establishing your risk model. So first of all, I'd like to talk through capturing what we call uncertainty. And really, in layman's terms, uncertainty within a risk model is nothing more than calibrating the schedule. It's looking at the durations and, as a project team, establishing whether or not we believe the durations are realistic or not. Now, that calibration process, the capturing of those uncertainties, is quite different to identifying key risk events. And I'd like to go into quite a bit of detail as to how risk events are captured in risk registers, how probabilities and impacts are scored, equally importantly, how risk registers can be valuable for tracking mitigation steps, but perhaps most importantly then, how do we feed those risk events in the risk register back into our risk model? The third step is running the Monte Carlo simulation, is running the risk analysis. And I would like to propose a technique for not just running a single scenario, but actually using a Monte Carlo simulation to generate alternate scenarios to give you more of a decision support, to give you more insight when determining go, no-go decisions on your project. Interpreting results. This is an area that's very interesting to me. Over the last 20 years, there have been numerous attempts at improving the reporting techniques around risk models, and unfortunately, it's my belief that we haven't made a huge amount of progress in risk reporting until recently. And so I'd like to touch on, again, some of the pitfalls to avoid when reporting risk exposure and risk drivers, and then introduce some new exciting techniques that we believe actually give a lot more detailed insight into exactly where is the risk, and again, more importantly, how to reduce it, how to mitigate it. And that really ties into the 5th step, the risk reduction. Some of you, as we were logging into the webinar, were asking whether we would touch on cost risk analysis. We do have examples of cost risk analysis, and what I'd like to share with you is an approach, a technique for not just running a cost risk model, but actually integrating the schedule model with the cost risk, such that the cost of time is taken into account in the cost risk model. Any questions throughout the webinar, feel free to use the chat or the raise hand capability of the GoToMeeting, and we'll wrap up with a Q&A session at the end as well. Now, I know many of you are very familiar with Acumen as a company. Obviously, we're a project management software analytics company. Our DNA, our core belief really hasn't changed in the past 5 years. We passionately believe that project success requires a sound schedule, a sound plan. Equally importantly, though, we believe that in order to forecast either a project completion or a project budget cost, you have to take into account risk and uncertainty. Now, that doesn't mean that we believe that forecasting has to be a soft, fuzzy, probabilistic view of the world. Absolutely not. A risk model absolutely still gives you a single point value. The difference, though, is it takes into account the likes of scope uncertainty and complexity of work, and it even can take into account historical performance of the project to help adjust and make the forecast that we're putting together in the form of a schedule, make that forecast more realistic. So if we take a step back for a moment, let's just consider the whole discipline of project scheduling. In my mind, project scheduling is really the science behind trying to forecast a project completion date. Now, today there are software tools that are extremely advanced with regards to CPM scheduling, but where they fall short is they still don't account for variability of scope, variability of duration, risk events or known unknowns. They still view the project, they still view the world as a finite entity. In other words, we will absolutely finish the project on this particular date. Well, to forecast or predict a project completion date, whether it's a year from now or 10 years from now, and predict completion on an exact date, it's ridiculously unrealistic. Statistically, you're going to fail. Instead, isn't it better to take into account uncertainty, risk events, those known unknowns, potentially the unknown unknowns, feed those into what we do know with regards to cost and schedule, and from that, develop things like confidence levels and potentially ranges within which we know we're going to fall, and then as the project moves into execution, try and home in and reduce those ranges back down to a single deterministic value. Now, with regards to oil and gas and EPC projects, typically on an annual basis, Acumen gets involved in approximately 50 third-party risk workshops. And what we're seeing is there's definitely an increasing trend whereby more and more projects today are developing what we call project risk registers. That is a list of identified risk events. Mitigation plans are starting to be established in those risk registers. But where we're seeing the separation from true risk analysis is that those risk registers are still then not being used as one of the inputs into the risk model. And so risk analysis really closes that gap because it actually gives you true insight into schedule achievability. You know, risk analysis is not about the chance of failing in my mind. It's the chance, it's really about, well, is the schedule achievable? If it's not, how do we make it more achievable? What is our confidence level? Where are our risk hotspots? So this is really really more of a teaser, I guess. So often we'll get asked, well, okay, so you know, why as a project should we even bother with this schedule risk analysis? We've already developed a very detailed schedule in Primavera. We know our first gas, our first completion date. We know the critical path. We know which areas of the schedule carry float. Well, I would argue pretty strongly that without running a risk analysis, you actually have no idea where the critical path is, and you actually have no idea how much float you're carrying in those non-critical paths. And the reason is this. As you can see on the screen here, we've got two key milestones that feed into our project completion. The orange milestone in the top left here is, in a deterministic world, is a non-critical activity. It carries float. That milestone can afford to be late without having an impact on project completion. The critical path, however, conversely in the bottom, this dark gray milestone, is absolutely critical. If it slips by 1 day, it's going to have a 1-day impact or a knock-on effect on project completion. So surely we should focus on this milestone in the bottom of the screen here. Well, not necessarily, because what if the non-critical path activity or activities carry risk and uncertainty? Those risks and uncertainty, if they eat sufficient float, then that float diminishes to nothing those non-critical activities become critical. My point is this: without running a risk analysis, we actually truly don't know whether the critical path is the critical path in the schedule. And so one of the massive benefits of running a schedule risk analysis is the revealing of what we call hidden critical paths in the CPM schedule. Another benefit is the ability to forecast how much contingency we need, whether it's schedule contingency or cost contingency. A really interesting soft benefit is the fact that as part of conducting a risk analysis and sitting down with the project team, whether it's a formal risk workshop or even just an informal interview session to understand the risk events and the uncertainty, you will actually gain a lot more buy-in from the project team on the project schedule. In fact, a risk workshop is actually one of the few times in the project lifecycle where you get the key team members of the project in a room together and actually have a focused review on the schedule itself. I know that today a lot of you work with the likes of IPA on certification, and so by conducting a risk analysis obviously goes a long way towards ensuring that IPA certification. So very quickly, just sort of I guess a sanity check on how does risk analysis work. So first and foremost, a schedule risk analysis should be based on a critical path schedule. In fact, a true schedule risk analysis software tool needs to have a CPM engine as part of the analysis. You can't run schedule risk analysis using the likes of Excel because a spreadsheet doesn't understand the complexities of calendars and constraints and everything that goes into a CPM tool, whether it's Microsoft Project or Primavera. You need to uphold the rules and the logic that a CPM tool will actually deliver. So a risk analysis is very much based on a CPM schedule, and the way it works is this. We run what we call a Monte Carlo simulation, which in reality is nothing more than hitting F9 in Primavera, for example. So it's running CPM analysis, it's doing a critical path analysis, calculating early and late dates, but it's running this CPM analysis thousands and thousands of times, taking into account the variability of duration and the potential impact of risk events. The thinking is that if we run enough iterations within a simulation, then within statistical reasonableness, we end up with a distribution of potential results. Now, one of the massive drawbacks of a Monte Carlo simulation is the results are highly prone to the inputs that you feed into the model. And again, you know, the whole concept of garbage in, garbage out is sort of a commonly thrown around phrase within the world of risk analysis. Now, I agree with that. However, I also believe that adhering to the steps that I'm going to walk you through in the next 45 minutes actually massively avoids this whole area of erroneous inputs driving erroneous outputs. Now, I mentioned earlier on that you know, we believe first and foremost sound basis of schedule is king, and secondly, you have to take into account risk and uncertainty in forecasting. So before a schedule risk analysis is run, it's very, very important to make sure that the underlying schedule is a free-flowing schedule. In other words, we need to make sure that there is continuous logic through the plan. We need to make sure that there isn't contingency or buffer already baked into the schedule. We need to make sure that the dates aren't artificially constrained. Now, we've done numerous presentations on the benefits of schedule diagnostics and schedule critique. So in the interest of time, I'm actually not, in this presentation, going to elaborate any further on this topic of sound basis of schedule, other than to say it's incredibly important that you pay attention to and give focus to ensuring a sound schedule before you even move into building a risk model. So alternate approaches to building a risk model. This is always nice and controversial. So there used to be a thinking that if you have a large schedule with hundreds or thousands of activities, then it's okay to just load either the critical path or the near critical path. The thinking being that, it's unreasonable to try and identify uncertainties on, maybe 5,000 activities. Well, this approach is just fundamentally flawed, because going back to my comments earlier about the fact you don't know what the critical or near critical path is until you run your risk analysis. So by just focusing on critical, near critical activities during a risk assessment, you're most likely going to miss some of the very key activities that you're trying to categorize with regards to risk and uncertainty. So to counteract that, another train of thought has been, well, okay, well, let's take our very detailed schedule and we're going to manually recreate the schedule, maybe up to 100 activities. So we're going to start with a blank sheet of paper, recreate the schedule in very much a summary form. That way then the project team can easily manage the uncertainty and risk loading on, say, those 100 activities. Well, the massive drawback of this approach is that what you're trying to do is manually, or you're trying to approximate the very detailed logic in your 5,000 activity schedule and approximate that up to the summary level. Well, you lose integrity. You can't build a summary schedule and have, or you can't represent the detailed logic in a 100 activity level schedule. And so it's very easy to shoot down a risk model if that risk model is not based on the true project schedule. So that leads me into really the third approach, and this approach has been adopted now by hundreds and hundreds of projects over the past 5 years. And the approach is this. First and foremost, you start with the true project schedule, whether it's 50 activities, whether it's 5,000 activities. And the approach is a top-down approach. So the idea is that, yes, you are still ranking activities with regards to uncertainty, but the difference is you're doing that by grouping activities, and it's a top-down grouping. So on the slide here, you can see an example where we've got a schedule broken out into early design, concept, detailed design, feed, procurement, so on and so forth. The thinking is that against each of these summary WBS groupings of activities, you can assign an uncertainty spread. Now, the way this works then is each activity within that grouping inherits that same categorization, but you still, as a project team, have flexibility of flagging by exception. So by doing this detailed, or by doing this top-down approach, you end up with the entire schedule still being loaded with uncertainty, but you don't have to manually walk through each one of the 5,000 activities in order to achieve that. We've called this the uncertainty factor approach, and let me just elaborate on that for a couple of minutes. So on the right-hand side here, you can see an example whereby our uncertainty factor template, we've got 5 different categorizations, and the categorizations on this particular project are based on historical performance. So when we're ranking groups of activities, if certain activities historically have always finished early, whether it's activities on this project or maybe it's similar activities on a previous project, those activities then get flagged and they inherit this this ranking on the right-hand side. Now, you may be thinking, well, okay, that's a really effective way of applying uncertainty, but isn't that limiting me as a project team member with regards to my ranking? Well, absolutely it's limiting, because what it's doing is it's avoiding team members coming up with crazy ranges. So to give you an example, if we have a 50-day activity and a team member says, well, the best case is 45 days and the worst case is 300 days, that 300 days, that's not a range of uncertainty. That 300 days is being driven by a risk event, in which case the risk event needs to be captured in the risk register. So by adopting this uncertainty factor approach, it's providing uniformity within the team, so everyone's working to the same scoring system. And secondly, it's avoiding very heavy skews, and those skews, like I say, are typically or normally risk events anyhow. So another benefit of the uncertainty factor approach is the old school approach used to be sit everybody in a room and force them to come up with minimum, most likely maximum ranges, distribution type, so it's a distribution triangular, uniform, beta PERT. I've even seen the examples of risk workshops where the facilitator has said, the only way I want you to describe the uncertainty on this activity is using a trigen distribution. So I want probability and values for the minimum most likely maximum. Well, team members are just going to laugh you out of a risk workshop if you adopt that type of statistical approach for ranking risk. And so this uncertainty factor approach, it still uses the statistical distributions and the min most likely max values behind the scenes, but in terms of presenting to the team member and the team member describing uncertainty back to the risk model, it's done in a much more meaningful context by using these uncertainty factors. So let me just show you a quick example of how that works. So here we are running Acumen Risk, and let's go ahead and for the purpose of our little walkthrough, we're going to grab a Primavera P6 schedule, and we're going to go straight into our risk view here. So here's our Primavera schedule. So again, we've got early design, concept, detailed design, feed, so on and so forth. And before we start our mock risk workshop, let me just show you our example here, our uncertainty template. Earlier, we had a template that was looking at historical performance. This is another example of an uncertainty factor template, but using a 5-point scale based on realism. So does the team member think the activity is very conservative or realistic or very aggressive? So to show you this top-down approach, let's go back into our schedule. And during the risk workshop, the team believed that the schedule as a whole was an aggressive estimate. So by sliding the uncertainty factor to the aggressive categorization, you'll notice that not only every WBS, but also every activity within the schedule automatically inherited that aggressive categorization. And you can see here within detailed design, the activities that are carrying duration, those durations you can see on the right-hand side here, minimum is likely maximum durations have been calculated based on that aggressive categorization. So aggressive was best case 95, most likely 100%, worst case 25% greater than the planned duration. So you can see our electrical activity as an example, 20 days. The worst case scenario there is 25 days based on that uncertainty factor. Now, going back to the top-down approach, the team during the project or the risk review may say, well, actually, hold on a minute. Yes, the schedule as a whole is aggressive, but detailed design doesn't fit the mold. In fact, detailed design is a very conservative estimate. So we can make detailed design very conservative, and then to take that a step further, the team may ascertain that perhaps the topside detailed design doesn't fit that rule, and in fact is very aggressive. Now, the reason why this is so effective, you can see here that in a matter of 3 rankings, we've actually assigned uncertainty to the entire schedule. In addition, if the team change their mind later on or want to reassess the uncertainty around detailed design, they can still go ahead and change the grouping as a whole, but because topsides was flagged as an exception, then topsides remains as an exception to the rule. So hopefully from this example, you can see that it's an extremely fast means of going through the different WBS categories, assigning those uncertainty factors. If you choose, individual activities can even be manually overridden with more of a traditional 3-point estimate approach. The groupings don't have to be WBS. It can be based on, for example, a code structure. So at this point, we're actually ready to run our first risk analysis. And in theory, we could run a Monte Carlo simulation, and we could start to look at the results. Now, we could do that. However, we've actually missed a fundamental component of the risk model, and that is really the second step, which is the identification and the capturing of risk events. So as I mentioned, risk events are captured in what we call a risk register. A risk event is a discrete event, so it's subtly different from uncertainty. Uncertainty on a cost or duration is largely driven by, for example, lack of scope definition or complexity of work, or as we mentioned, past performance, or maybe just the duration is just plain wrong. Whereas a risk event is an external event that has a probability of occurring, and then if it occurs, it will then have a cost and potentially a schedule impact on either an activity or a group of activities. Now, when people think of risk registers, I think for the most part they associate risk registers with risk events in the form of threats. I would strongly advocate tracking both positive risk as well as negative risk. In other words, track the potential good things that can happen in the form of opportunity. Now, in a risk register, I would also advocate that you should track multiple states. In other words, interrogate the project team and interview them as to what do we believe the current probability and the current impact is on the risk, but then also take it a step further and say, okay, well, for those risks that look like they have a high impact, do you have a proposed mitigation plan in place? And if indeed you execute that mitigation plan, what do you believe the residual or the mitigated score will be? So where I'm going with this is a risk register can actually be a means of tracking multiple states of a risk. And the nice thing about that is in a few minutes then, when we start to run the risk models, we can actually run multiple scenarios. We can run a scenario which shows us our current risk exposure, and then we can compare that to our mitigated state, our forecasted state, if indeed we were able to sponsor that mitigation, compare the two, and then look at the return on investment for that risk reduction. Now, before we capture risk events in a risk register, it's very, very important to undergo what we call risk register calibration. So many organizations today have a standard or a corporate risk register scoring mechanism, and that's largely been driven through the likes of HSE-based risk registers. Now, in theory, I think it's a good approach. However, in reality, it causes a major problem with regards to project risk analysis. And the problem is this: if, as an organization, we define maybe a 5x5 risk matrix, and 5x5 is today a fairly common mean, so 5 buckets for probability, 5 buckets for impact, as you can see on the screenshot on the right-hand side here. The problem, though, is that those buckets, you'll see here we've got very low through very high, and we've got schedule impact and cost impact. Those schedule values and those cost values need to be within context of the project. If we've got a 30-day TAR or shutdown project, then having a scoring mechanism whereby very high is greater than 50 days may not necessarily fit. Conversely, if you've got a 10-year project, the scale, it wouldn't be a realistic scale because you'd have some risk events that are potentially 6 months to a year. So it's really, really important to calibrate your risk register, your risk matrix, before you start identifying risk events. And again, in Acumen Risk, there's actually a utility for automatically calibrating your risk matrix. So again, it's another step towards taking out one of the potential pitfalls that a lot of projects fall into. Relative or absolute, this is really techie speak for when we identify the impact of a risk. Do we want to specify it in terms of true duration? In other words, a labor strike may have an impact of up to 30 days, or do we want to describe that labor strike risk as, well, it's going to have an impact on the work, and the impact may be as much as 50% of the duration. So having the flexibility of identifying and defining the impact of risk, both from an absolute perspective in terms of true duration and cost, or a relative perspective to the duration and cost of the activity, gives you a huge amount of flexibility, and that flexibility, again, pushes you towards a more accurate risk model. Risk matrix thresholds. So there has been a lot of talk and, again, controversy around the value or the lack of value of what we call thresholds in a risk matrix. Now, thresholds are essentially these color scales. So in my example here, I've got red, yellow, green. The theory being that the red risks are the big risks that we need to focus on. The green risks are the low risks. We don't need to worry about them too much. Again, I would throw out the comment that you actually have no idea whether a risk that ranks highly in a risk register, how do you know that that risk is truly going to have an impact on either your project schedule or your project cost? without running your risk analysis. To give you an example, if a risk event has a potential of maybe a 6-month delay, is that risk high risk to first gas? Well, you might think yes. I would argue you actually don't know, because if that risk event is impacting work in the schedule that carries 7 months worth of float, that 6-month risk is just going to eat 6 of the 7 months of float. You're still going to have a month's worth of float. It's not going to have any impact whatsoever on the first production date. And that is really one of the main reasons why it's so important to conduct a quantitative risk analysis in the form of a Monte Carlo simulation. So once we've identified and scored the risk events, the final piece to the puzzle is then to plug, if you like, to map and embed the captured risk events back into the schedule model. A few minutes ago, we showed an example where we brought in our Primavera schedule, we assigned uncertainties, and we were sort of in a position to run our risk analysis. We've now got to the point where we've identified our risk events. However, we've got to tell the model, well, where in the schedule do these risk events happen? So the way this works is through a mapping utility, and it's very, very simple. For each of the risk events in the risk register, we tell the risk model where in the schedule we believe they're going to impact. So in our example here, we've got a hurricane risk, and we've got a labor strike risk, and we can see that our hurricane risk has a potential impact on transportation, which is a 5-day activity. It also has a potential impact on commissioning, which is a 20-day activity. So by mapping the hurricane risk with a 25% probability of a further 10-day impact, the model then inherits that hurricane risk and connects it to that activity. Now, the labor strike risk, you can see here, instead of being defined as an absolute value, it's actually defined as a percentage of the duration, so that when it gets assigned, first of all, to construction, it's 50% of the duration of the activity, in this case 15 days, whereas that same risk event, when it impacts commissioning, you can see here 20 days, 50% of 20 days is 10 days. Okay, so it's flexible in terms of not just the mapping to groups of activities or individual activities, but also the spreading and the prorating of the impact across those activities. So again, let's give this a little bit more context. Let's go back into our risk model here, and let's bring up the risk register. So against different activities or groupings of activities, so let's go to construction, for example, we could say, okay, there is a potential threat of a labor strike that would impact the whole of construction. So we can click on the little risk icon, and let's do labor strike, and based on our defined calibration, we could say we believe there is a high probability that there is a labor strike that could be as long as 40 days. And what you'll notice is now that labor strike risk event, because we associated it with the whole of construction, every activity within construction, you'll notice now has a little yellow risk event icon next to it. Each of those individual activities is taking a hit from that risk event. Now, it's actually a little bit cleverer than just assigning the same risk to multiple activities, because what's happening is the model is taking into account the fact that each of these activities within construction have different durations, and so our 40-day risk impact is getting spread and prorated, as you can see in the bottom here, relative to the duration of the activity. Now, if I wanted, I could override this. I could turn risks on and off, or turn, I could say, well, actually, the labor strike risk is going to impact everything other than site clearance, because site clearance is done by a different subcontractor. So again, it's not hard and fast, but it's a very, very fast means of capturing and identifying and mapping the risk events. Most projects, as I mentioned, today track risk registers or track risk events in some form of external, whether it's an in-house or a commercial risk register. And so we've made it very, very easy to import existing risk registers. Here's an example of an existing risk register from a third-party risk register application. Scrolling over to the right, you can see an example here where the project team have identified not only the current state and the current scores of the risk events, but also the mitigated state as well. So at this point, we are actually truly now in a position where we can run our risk analysis. So we've captured uncertainties, we've identified our risk events, we've mapped the risk events into our schedule, we're ready to run our simulation. So some of the options that really require some consideration. Again, a common question is, well, shall I just run 1,000 iterations? I don't know how many iterations I should run. Well, you can run a fixed number of iterations. However, we would suggest let the model determine how many iterations it needs in order for the results to be statistically accurate. And so there is an option whereby Acumen Risk, as an example here, you can actually just tell it, keep running until the results don't change by more than 1%. Well, if I can get my forecast for a 4-year project and get my risk-adjusted forecast to within 1%, I'm doing very, very well. Alternate scenarios. So we just touched on the fact that in our risk register, we have current state and we have mitigated state. So here you can see an example whereby we can very quickly run a scenario where maybe we just want to look at the impact of uncertainty, or we want to look at the risk exposure taking into account risk events without the benefit of mitigation. Or maybe we do want to take into account the positive impact of mitigation, but exclude the cost of mitigation, because mitigation doesn't come for free. And so the model is even clever enough to say, well, I can differentiate between the benefit of mitigation, but I'm going to offset that benefit with the disbenefit of the time and money and effort it's going to take to do that mitigation. Hierarchical risk models. This one's very interesting. So there is a challenge when running any form of simulation against any type of hierarchical model. So this doesn't just pertain to schedules, but there is an issue whereby if you have a hierarchy of data and you run a Monte Carlo simulation, there is the model is prone to the children elements potentially canceling each other out. So if you have 2 children activities within a summary, and the first child activity is a very aggressive estimate and the second child activity is a very conservative estimate, then those 2 sort of competing activities, if you like, potentially cancel each other out. And so as you roll up the results through the WBS or the summary, you lose the true impact of risk. And so again, we've made it super easy to avoid this issue of what's known as central limit theorem, or the avoidance of the issue with hierarchical risk models. So again, behind the scenes, through the use of correlation, Acumen Risk will take care of all of that. So risk reporting, we're now in step 4 of 5. There are really 2 core risk reports that you should carry in your risk toolkit. The first is what we call a risk histogram. I call this the what report because it tells you what is your risk exposure. And then tied to that is the tornado chart, which is the why, which tells you why is your exposure what it is. So just to focus on the histogram, first of all, people throw out this terminology or this phrase, this P-date term. And you may have heard of P50, P75 dates, for example. So a P-date, you can see here on the right-hand axis, we've got a probability scale of 0 to 100. A P-date, let's take maybe P50, is a date that we are 50% confident we will achieve. Whereas a P80 date, look, you can see the P50 date here is the 19th of February. The P80 date is later than that. It's the 28th of February. So we're 50% certain we can finish by the 19th. However, we are 80% confident we can finish by the 28th. Now, contingency is the difference between a confidence level, or a P date, and our deterministic finish date. In other words, if our deterministic date in our example here is the 4th of February and our P50 date is the 19th of February, then our P50 contingency is 15 days. Now, what is that really telling us? It's telling us that we are going to be, we've got a 50% chance we're going to be 15 days later than expected. So the way to overcome that is to go ahead and buffer your schedule by 15 days. In other words, set the expectation that you're not going to finish on the 4th of February, you're going to finish on the 19th of February. Well, I don't think that's a very proactive way of managing risk. In many ways, it's covering yourself. You're just moving the goalposts. What I would advocate is actually don't buffer your schedule with contingency. Use contingency as an indicator as to how much acceleration you need to achieve on the base schedule, so that if the risk happens and that 15-day risk exposure hits, and yes, it can hit, but because you've accelerated and compressed your schedule, then you'll still achieve your target date. So don't just think of contingency as a magic bullet. In fact, it's not. It's just a buffer. Now, confidence level. Confidence level is the probability of you hitting your scheduled completion date. And this is probably the most misunderstood and misused schedule risk metric known to mankind, because what it does, it tells you, as I mentioned, what is the probability of hitting your schedule date. Well, because schedules are driven by logic and schedules carry multiple paths, one of the problems with the confidence level metric is that even in a schedule as simple as 2 parallel paths, even if both of those paths have let's say a 50% chance of coming in late or a 50% chance of coming in early, the probability of both of those paths finishing on time so as to not impact the first gas or first production date is not 50%, it's 50 times 50, which is 25%. Well, that's a simple schedule with 2 parallel paths. Take a true schedule, even with 50 activities, which may have 4, 5, 6 parallel paths that all converge to first gas. That confidence level is inherently going to be very, very low. So I would actually throw out there that confidence level is, again, it's somewhat of a fundamentally flawed risk metric. And in fact, I would use confidence level as a means of reporting how complicated your logic is. Now, that doesn't actually help us, right? Because I'm suggesting that confidence level is a dangerous metric. So is there another metric out there that is actually a better representation of risk exposure? Well, we've developed a metric called the risk range factor. And the risk range factor looks at the range of risk exposure. So it looks at the best case scenario, the P0. It then compares that to the worst case, the P100, and that determines your range. So in our example here, our range goes from the 21st of January through the 25th of March. So that's approximately a 3-month spread. That 3-month range, if you then compare that to the duration of the project, perhaps it's a 3-year project, then approximating the math there, 3 months uncertainty or 3 months risk exposure over 3 years is about a 10% risk exposure variable. And so reporting that with the work remaining, there is a 10% variability with regards to risk exposure is a much more meaningful metric than going back to management or going back to the sanction board and going, okay, well, we got a 3% chance of coming in on time. That confidence level is a very, very misleading metric. So talking of misleading metrics, the tornado chart. So historically, we have used tornado charts to report which activities or which risk events are the most impactful on our project completion. And tornado charts have used metrics such as schedule sensitivity or criticality, or years ago we introduced a metric called cruciality. Now, schedule sensitivity is it's a correlation coefficient, so it's a percentage-based tornado. And like I say, again, it's one of the most misunderstood reports, because people look at a traditional tornado chart with percentages on them and think that those percentages are, for example, the probability of that activity being the biggest hitter. Well, it's not. It's a correlation between variability of duration in the activity versus variability on the finish date. Well, trust me, try explaining that to a project team, a project manager, a sanction board, a funding board. People don't get it. They look at you with a blank stare. What they're asking for and what they're wanting is, well, tell me the big hitters, tell me the activities, tell me the risk events, and tell me in terms of duration and cost, because ultimately that's what we're sanctioning the project around. So don't talk to me in terms of correlation and the schedule sensitivity. Give me a list of activities or areas in the schedule and tell me how much they contribute to our risk exposure. And that's exactly what the risk contribution factor tornado chart does. So it is a true measure of the impact on our project, and it's a measure in duration and cost. So there's an example of this on the right-hand side here. Our P50 date, you can see, has a risk exposure of 103 days. In other words, we are 50% certain we're going to be 103 days later than planned. That 103 days is driven by 34 days because of site clearance, 16 days because of phase 4, so on and so forth. Now, taking that a step further, we've even now established a means of saying, okay, well, site clearance is it's causing a 34-day risk exposure. However, is that 34 days because of uncertainty of duration, or is it just because it's getting hit by a risk event? And so the report here, look, by segmenting the bars and differentiating between inherent uncertainty, so the green is uncertainty, the color-coded bars here, so this site clearance with this risk number 42, look, it's interesting because actually, even though site clearance is by far the biggest risk driver, the scope definition and the uncertainty of site clearance is negligible. It's about a day. What's hurting site clearance is risk 42, which is the risk of inability to hire craft to maintain labor curve. So again, it's a much more insightful way of pinpointing risk drivers, because now instead of trying to home in on the duration on site clearance, we know that we actually need to home in on the mitigation plan that we put aside or that we planned for that risk 42. So again, let me just give you a quick run through of that. So let's run our risk analysis. And again, now let's go to, say, project handover. And earlier we touched on being able to report contingency. So in our example project here, handover is scheduled for the 26th of December. Our P50, though, isn't until the 29th of April the following year. Our P50 contingency, boom, 124 days. So we have a 50% chance that our project is going to be 124 days later than planned. Okay, that's interesting. Now I want to know the reason why that exposure is what it is. So let's look at our risk drivers. And before we get into the weeds here, then perhaps we want to report this up to management and start off by saying, well, okay, well, if we just show this at the WBS level, then that 124 days is largely being driven by construction. So 73 days by construction, 31 days by manufacturing, so on and so forth. Okay, so I understand that construction is the area where we need to focus most. Can you tell me now within construction which activities? So now let's drill down and say we want to differentiate between risk events and uncertainty. So I can see that construction as a whole, there is 36 days of uncertainty. There is 38 days being driven by risk events. Okay, can you now tell me which activities within construction? It's as simple as drilling down into the details here, and we can see that it's site clearance, domestic electrical, so on and so forth. So it's very, very easy to slice and dice to drill down. Many of you have also said, well, okay, it's interesting to look at the activity hotspots, but I need to be able to report back to my manager. You know, my manager is looking at the risk register and saying, well, okay, the top 3 risks in the risk register, are they big hitters in the schedule? So by rotating the tornado chart here, what we're looking at now is the risk events, and by risk event, look, it's now showing how much impact on each activity is that risk event happening. So risk number 9, risk of delay due to fabrication yard constraints. Okay, that's interesting, but it's, you know, which activity is it hurting most? Well, it's hitting activity 470, which based on the key down here is phase 4. So being able to not just say that the fab yard constraints is the second biggest risk, but actually pinpoint where in the schedule is that risk hurting us. So to wrap up the 5 steps, risk reduction, we walked through an example whereby we captured uncertainty, we looked at the impact of risk events, and again, really just to close off and take that a step further, if we go back into our risk model, so let's go back to our scenario that we were looking at. We were looking at our 124-day risk exposure. The model that we ran, the scenario that we ran, was uncertainty and risk events, but excluding mitigation. So what will be interesting now is to say, well, okay, we saw earlier the team capture mitigation plans. Let's go ahead and see the positive impact of that mitigation. So let's quickly run the model, for the third and final time, and let's go to our comparison chart now, and what this is now showing is the difference between our mitigated, this is our non-mitigated, and this is our mitigated scenario. And we can see now that our mitigation will actually save us 50 days. So the question then is, okay, well, we know how much the mitigation is going to cost. When we go to our sanction board or the management team and go, okay, are you willing to sponsor this amount of time and money in order to save 50 days on the project? Okay, so let's take a pause and take a little bit of a different direction now and consider cost risk models. So everything we've talked about so far has been very heavily focused around schedule risk analysis. So let's go back into our risk model, and let's now consider running a cost risk model. So most cost estimates are, again, developed in third-party cost estimating tools, or let's take something as simple as cost risk estimate in good old Excel. So here we have a cost risk estimate. This is a deterministic estimate. There is a cost breakdown structure you can see here. So it's broken out into G&A, drilling, subsea, so on and so forth. There are actualized costs, remaining costs. So this cost estimate can be directly loaded into Acumen Risk. We'll specify how we want the hierarchy developed. So the benefit here is that we don't have to go through the often treacherous lengths of creating a resource or cost-loaded schedule. You know, very often a cost estimate, the structure, the cost breakdown structure isn't one-for-one with the WBS structure in the schedule. And so rather than forcing you to create an artificially cost-loaded schedule, our approach is very simple but very effective. So you can see here that we've brought in our cost estimate. Here's our remaining cost. Let's go back to our risk model. And in the exact same way that earlier we assigned our uncertainties to schedule, we'll do the same thing to our cost estimate. Let's make our drilling costs very aggressive. Let's make our platform costs realistic. Let's make our subsea costs aggressive. Maybe there's some exceptions to the rule within the procurement of trees. Okay, so again, we are assigning uncertainties to our cost estimate. And at this point, we could run our cost risk analysis, and in the same way that we reported contingency and drivers earlier for schedule, we could do exactly the same thing for cost. Actually, this is quite interesting because what it's showing here is that for the trees, there's actually too much cost baked into the estimate already. Let's go back to the total project cost, which is sitting at $4.5 billion. So our contingency right now is $60 million. Now, while that is a reasonable cost risk model, what we haven't done is taken into account the fact that some of those cost elements are time dependent. And so if some of those durations in our schedule model slip because of risk, then that needs to be taken into account when the cost risk model runs. So the way this works is we actually link and merge our schedule risk model with the cost risk model. So for those cost elements that are time dependent, you actually map those time dependent costs back to elements within the schedule model. And then what happens is the distribution, the risk exposure from the schedule model gets overlaid and incorporated into the cost model. Again, let me just show you a real world example of this. So in our cost estimate here, let's go to maybe our G&A cost. So we've got G&A costs, and let's assume that these costs are time dependent. Then it's as simple as saying, okay, we want those time dependent costs to be driven by the schedule model, and perhaps it's not the whole of the schedule, but instead maybe it's just the construction period of the schedule that is going to drive the cost. So we're linking the construction schedule risk profile back to our cost model now, such that when we run the model now for a final time, again, our total contingency was $60 million. You can see there. Now, if we run it for the final time, it increases, look, to $250 million. So what is that telling us? Well, what it's telling us is let's go to our risk comparison. And actually, sorry, folks, I needed to go back, and I didn't take a snapshot without the impact of time. So let's go back to our base case without consideration of time. We'll take a snapshot and then compare that to the scenario we just ran with the impact of time. And what this is showing us now is the increasing cost because of that schedule delay driven by schedule risk exposure. So that's a really effective way of saying, okay, we've got a schedule model, a schedule risk model. We've gone to great lengths to generate a very accurate schedule risk model. We've taken our cost estimate. We haven't had to approximate or try and artificially wedge a square peg into a round hole with regards to taking the cost estimate and trying to spread it into the schedule. We haven't had to do any of that. We've built our cost risk model and simply linked the time-dependent costs back into the schedule model and then let the model take that into account. And again, from this point forward, the reporting for cost risk is exactly the same, whether it's looking at individual cost elements, rolling up through the cost breakdown structure, so on and so forth. Looking at potential opportunities, you can see here in subsea, as well as negative risk in drilling and G&A and platform costs. So that was a fairly fast and furious run through the 5 steps. What I'd like to do now for the closing couple of minutes in the webinar is an open Q&A. So I know we've got a list of questions that you've already compiled. I'd like to go through those. And then as I'm going through those, please use the chat feature in the GoToMeeting to ask additional questions. So one question is, we have a 6,000 activity construction schedule that we know has quality issues, games played by the contractor to get the schedule in on time. Is it the norm? Is it worth doing a schedule risk analysis on the schedule, or should we create a cleaned up summary schedule? Really good question. My advice there would be, okay, so I would first of all run a risk analysis on the contractor schedule. Well, as a precursor, I would run a schedule diagnostics. I would use Fuse to look at the schedule integrity. I'd make sure that they score at least 75 on the schedule index. If they don't, I would go back to the contractor and show them where they need to fix the schedule. But I would run a risk analysis on the contractor schedule, because then that gives you ammunition as the owner to sit down with the contractor and go, look, based on the schedule you're putting forward, the risk exposure is this. Now, if you don't believe or don't have buy-in into the contractor schedule, then yes, I believe there is additional value in creating your own interpretation of the schedule. However, at the end of the day, if it's the contractor executing the work and you're tasking them with generating a forecast or a plan to do that work, I would lean towards working with the contractor on fixing the flawed schedule and using the contractor schedule. And again, we've seen in numerous instances an owner conduct their own owner risk workshop. They're relying on the contractor schedule, and they do a schedule cleanse, again, for example, in Acumen Fuse, before they do the schedule risk workshop. There's a question here, and I'm smiling as I answer this or read the question. How does Acumen Risk compare to Primavera Risk Analysis, which used to be the old PertMaster product? We do actually have a comparison document that happy to share with anyone who's interested. I guess at a high level, PRA is obviously a very powerful tool. It's also a very expensive tool at about $12,000. So you know, Acumen Risk is about a third of that price. But more importantly, putting costs aside, Acumen Risk was designed from the ground up to be usable by project teams, not just from a building the risk model, but from interpreting and analyzing the results. We actually made a purposeful, we didn't want to just reinvent PRA or PertMaster. That wouldn't have been valuable to the project world at all. We've seen over the last 10 years that projects struggle with, this is going to sound somewhat ironic, but projects have struggled with the complexity of PRA. There's so many bells and whistles. You know, it's very, very powerful and capable, but I would diplomatically argued that it is somewhat divorced from the real world and the world that projects work in. And so again, things like the uncertainty factors, the tornado charts that are duration-based rather than correlation-based, much more meaningful. And I think there's a question with regards to correlation. So yes, Acumen Risk does fully support correlation. You can correlate between activities. There's also an automatic correlation to overcome central limit. Risk events can inherently be correlated. So again, I'm more than happy to offline go into the details and the weeds on correlation. But yes, we support correlation. We also support correlation between duration and cost as well. And I think the final question that we haven't answered is the webinar being recorded? Well, that's an easy one. The answer is yes, and we will be publishing the webinar on our website over the next day or two. So I think with that, let's go ahead and wrap up. If any of you are interested in more information about the theory behind risk and risk workshops, or would like perhaps a trial version of Acumen Risk, then our website is projectacumen.com. And as always, I'm always personally contactable. My email address is dpatterson@projectacumen.com, and more than happy to answer any questions. So with that, again, I'd like to thank all of you. I know it was a huge audience today, so thank you all very, very much. I know we've had people dialing in from all four corners of the globe, so thank you for your time. And as always, I hope it was a useful and informative session. So thank you all very much.